Question 11. In the diagram below, the monochromatic light is incident on the metal plate of a photocell. A sensitive ammeter shows a reading. 11.1.1. How does the energy of the photons of the incident light compare to the work function of the metal plate? Choose from greater than, less than, or equals to. So they are saying that the ammeter shows a reading. That can only mean that the energy of the photons is greater than the work function of the metal. So now we have to give a reason. Well, the reading on the ammeter indicates the flow of electrons or the flow of charge. .1.2. When a change is made to the monochromatic light, the reading on the ammeter increases. A learner makes the following statement with regard to this change. The increase in the ammeter reading is due to an increase in the energy of the incident photon. Give a reason why the statement is incorrect. Okay, so when you increase the intensity of light, that causes an increase in the ammeter reading. So an increase in intensity only affects the number of photoelectrons that are ejected per unit of time. It does not change anything else except the number of photons that are ejected per unit of time. So an increase in the ammeter reading is due to an increase in the intensity of the light. So an increase in the ammeter reading is due to an increase in the intensity of the light and not due to an increase in the frequency of the light, in the energy of the photons. 11.1.3. What does the photoelectric effect tell us about the nature of light? Well, it tells us that light has a particle nature. Because if you remember, we have the wave-particle duality, which tells us that light can either be a wave or it can behave as a particle. So the photoelectric effect focuses on the particle nature of light. Ultraviolet radiation is incident on the surface of a sodium metal. The threshold frequency for sodium is 5.73 times 10 to the exponent of 14 Hertz. The maximum speed of an electron emitted from the metal surface is, so the speed is 4.19 times 10 to the exponent of 5 meters per second. 11.2.1. Define or explain the term threshold frequency. So this is the minimum frequency that is required in order for electrons to be ejected from a metal surface. calculate the 11.2.2, the work function of the sodium. The work function is equals to Planck's constant multiplied by the threshold frequency. And then we are given this as 73 times 10 to the exponent of 14. So I am getting 3.80 times 10 to the exponent of negative 19 joules. 0.3. The frequency of the incident photon. Energy should be equal to the work function plus EK max. E is given as h multiplied by the frequency, the work function, plus half the mass of the electron, V squared. This is 6.63 times 10 negative 34, the frequency. The work function is 3.80 plus half, 9.11 times 10 negative 31. And the speed is given as 4.19 times 10 exponent to 5 all squared. So I am getting the frequency as 6.94 times 10 to the exponent of 14 hertz.